Hello everyone, good afternoon. Today I'll be talking at a larger scale than Tim was talking about, to talk at the family level, just to highlight a couple of techniques that we've used recently in our projects to come up with solutions for some needs that we were facing. So we'll be talking about first how to use the detail levels. This might not be entirely new to yourselves, but some might be, so try to cover all levels of knowledge here. And then we'll be talking a bit what are the nested shared families and how to use them for particular purposes. So on detail levels, anyone knows what the detail levels are for Revit? Okay, so basically it's a view instance property. You can't change it. You have three of them: the coarse, medium and fine level. You can set it up on the, can I move the mouse? Yes. So at the bottom of each window you can set the detail level for that particular view to be coarse, medium or fine. You can also set it up on the properties view if you have nothing selected under the graphics section. You can also assign it to the view template, so that if you want a set of views to share the same detail level, you just lock them by choosing the detail level here. And also on the VGO window, the visibility graphics override, you can specify that for that particular view there is one specific category of elements that is using a different detail level. You have four different options here. You can, the default setting is so that all categories are shown by view. The detail level for all categories is by view, meaning that it's driven by this setting over here, or you can override it by choosing, say in this case, the railings can be shown for this particular view just at coarse, medium or fine. So what the detail level does is it determines the visibility of elements at different levels of detail. The example that we have, that I brought here today, is for railings. So you have three different levels of detail for the same railing, and you can see how different it is visually. So you have the coarse scale where there are some elements that are not missing. You have the medium scale where the elements is simplified, and at the fine level you have all the curvy bits of the baluster for this railing. So this is using the same baluster family, but just changing the detail levels of the elements that compose it. We were using this to create a scoping elevation, and it's a GA elevation. So when we plotted it, we noticed that the railings were turning rather heavy. Why? Because they were using the fine detail level, and it didn't feel right visually with all the rest of the elements for that particular view. So what we did, we then went and changed just the baluster family for this particular railing, so that at coarse scale things are more balanced here. At medium it's still a bit heavy, but not as much as the fine detail. So how did we do it? There's a small video here. So at the bottom we have the baluster family here that is used, and currently it shows the same whether it's coarse, medium or fine. At the top we have a project sheet with the three views, each one with different detail level settings. You can see that this one has the detail level property set to coarse. The one in the middle has it set to medium, and one at the right, the detail level is set to fine. And they all look the same, because this was the baluster family as it started. It was modeled that way with all the curvy bits, because they were really keen on getting the full detail of that baluster. But for the G elevations it was not working quite well. Okay, the video is a bit sluggish. So as you can see, either at the coarse level, the detail is pretty much the same. I'm sorry for this. I could speak a bit slower, but I didn't rehearse it that way. Okay, so the first step that we did was try to remove the elements that we really didn't need to the core scale. The way how you do it, so in the family editor, you just select an element. In this case, that's an extrusion. And then, after having the element selected, you go to the top button and you can see that you have the detail level. All the 3 detail levels below are checked: the coarse, medium, and fine. These are visibility settings for those particular elements. So in this case, we unchecked the detail levels for coarse and medium and kept the fine detail level for these elements. And now we're going to load it back to the project. And you'll see how the coarse and medium views will update to match this new version of the baluster family. I'll need to choose to override the existing version because I'm overwriting the baluster family loaded into the project file. See, so they're missing because at the coarse and medium we've set them to be hidden. Okay. So the next step would be to simplify one of the main elements. So it's an extrusion, so to make things quicker, we just edit the sketch and copy paste it to the same place. So within the same family, I'm going to overlap 2 extrusions for the same element, one to a more simplified version, and keeping the one that is modeled with all the arcs and curves for the fine. So I'm going to paste the sketched. Try to paste it to the exact same location. Okay, I could probably speed it out a bit. So I've simplified this. Oops, sorry. Okay, so I've simplified the element at the bottom, so it's just squared. I've deleted all the other elements. Sorry, I think I forwarded too much. Okay, so the element at the bottom is simplified, so I keep the coarse detail level visibility setting checked, and I uncheck the fine one. Sorry, I keep the coarse and the medium, so that when I load it, it shows a simplified version of that element for both coarse and medium. And now the approach for this baluster was that to get the medium detail level, we were to simplify the very convoluted shape of the baluster elements that were used at the fine level. So we created new extrusions, and this time literally like cutting corners. So rather than using all the arcs and circles to create extrusions, we just use straight lines. And the number of segments that you use also has an influence on well, I'll show you afterwards, on also not only the visual but also the speed and the size of the PDFs that you will generate. So as you can see, this is a much more simplified version of the finer detail level element. Okay, I will speed it up a bit now. Modeling the bottom half. So you can see at the top, like the one at the left, it's the medium detail level, and the one it's the fine detail level, which when you zoom in, it's relevant. But for those particular GA elevations that we were working with, like it was meaningless, the differences for the end result. So after finishing the extrusion, loading into the project, and by using the same exact baluster family, and by just tweaking the visibility settings at the for the detail levels, you can have the same railing family, which can then match the. It's a better match for the scale that you want to use for your GAs. And of course, you should set the views detail level according to scale. Say, for instance, if you use the coarse detail level at a 1 to 20, where you're showing the railing, of course, it's going to look very crude, right? So it's a matter of tying this to the scale. A suggestion would be via the use of a view template, where you have a set of, say, GA elevations. They're using the same exact scale and the same detail level. And not just visually, so there's also an impact on the different levels of detail. So we timed the time that it takes to create the PDFs for each detail level, which you can see on the graph on the right, and the PDF size on the graph on the left. So blue for coarse, orange for medium, and gray for fine. And you can see that there's a huge difference. This was just one GA drawing. That scoping elevation. At the coarse scale, it was around 6 meg. At the fine detail, it was roughly 16 megabytes, one PDF. And also the amount of time that it took to generate the PDF for the two different detail levels, it was quite significant, from 5 minutes 40 to 8 minutes 40. Now, if you time this by the number of PDFs that you need to produce throughout the lifetime, yeah. 2015. 2015. So you could see that not only you could get a more consistent view, like visually, that the railing doesn't seem that heavy on the elevation, but you can also get benefits while creating the documentation, especially if you need to do it like repeatedly for different issues or whatever. Any questions for this bit?
Could you not have achieved exactly the same result using model lines on the physical and model, and then you haven't got the heavy handling geometry at all?
We could, but as a company strategy, we tend to actually model the elements and tend not to use model lines. But that could be a workaround, yes. Yeah. Okay. Moving on to nested shared families. So, what are nested families? Nested families are just families which have been loaded into other families. Okay, and you can nest families within other families to create new families that contain the combined family geometry, and also benefiting on the use of the family type parameter that you can use in families. Another video. Let's hope it's not that slow. So what we had here, we had a Georgian window, and we wanted to create a different type where the only change that occurred was the type of pediment. Here we have a straight pediment. We had a family here, and we wanted to create a different type, but with an arched pediment for that window. So rather than doing a save as for that window family and then modeling the arched pediment at the top and then loading a different family, whereas the rest would remain the same, we thought on just modeling the arched pediment as a separate family and then nest it into the main Georgian window family. Does that make sense? Okay. So the straight pediment is also a nested family, so as are all the other components there. That's the name of that family. All these are of the category window families. Okay, and I'll so that they were more manageable. So because they were hosted on the main window family, we thought, oh no, I'll just make them their category for consistency be all of windows. So you have the fan light, the surround, the other frame. All of them are just nested window families into this one. And you can see in the project browser here at the bottom, you have all the nested the nested families here. So first let's create the family type parameter. The quick way of doing it is just select one of the nested families of the category that you want to create that family type for, and then in this case we just name the parameter called pediment type. And you can see at the bottom, or probably you can't see it. Okay. Can you read this? No. Okay. Okay. So let's try to use the trick that Drop showed me. Not working. Control 1. Yeah. Oops. Okay. Actually, let me go straight to the family. Okay, so here, this was the family without being edited. So you select the family. This is a nested family of the window category, and then you add the parameter, right? And then because you've picked a nested family of the window category, Revit fills in this space here automatically. So it's going to create a type of parameter which is of a family type for windows. So let's just pediment type. So now on the type properties you have a different parameter called pediment type, that where you have a drop-down box and you can pick from any nested family in this main family whose category is of the window type. Okay, if I had a generic model family nested into this main family, selected it and then created the parameter, that would pick up from all the nested generic model families on this main family. Okay, let me move this one. I'm just showing where the new parameter is. So after creating this new parameter, all I need to do now is to load the arched pediment into this main family so that it will be available in the family editor under the project browser on the left, and create a new type and pick the new arched pediment. So we have the arched pediment. Let's load it into the family, which in this case it's called main. Well, it's the second one. Gonna have to trust me on this one. Okay, so click OK. So it's going to nest this family into the main family. We don't need to place it. We can cancel that because all we wanted is to load this family to the main family. It's there at the bottom now. And now we can go on and create a new type. Previously we only had one called pediment. Now we're going to create a new family type and call it pediment arched. If the video allows. Okay. Okay. I apologize for that. There was a problem with the video. Okay, so the pediment arched. Let's load it into the main family. It's here. I'm going to cancel because I don't need to place it. Oh, incidentally, the place where you model the different families that you're going to nest matters, because this one was modeled so that the reference level for this family was sitting here, and the reference level for the other arched pediment needs to match, so that when they are replaced and fall in the exact same location. So the pediment arched family is here. It's already nested, so we can go and create a new type. Okay. Anyone with a tip and trick on how to reveal the
Is that one you just have? If they change it, just to the right and pull down left on.
Oh, okay. Okay, sorry. I've been working too long in 2015, I guess. So let's call this pediment arched. Click OK. Now going to that parameter that was created a while ago and select the pediment arched nested family. Click OK. Of course. So now if we switch between types, you have the same family with multiple ones. Now you can do this. You can do this with all the other components. Some you might need to associate the parameters so that if the height changes, the height of the nested element changes, this around also changes. But it would be a matter of identifying the key parameters and disassociating them. But the principle is the same. Now, this has some pitfalls, like for instance, you could accidentally choose to apply the surround, which may not look very good. So far it's not possible for you to create a parameter and just filter and lock it to a particular set of nested components, so you need to be a bit cautious about that. But I would say that if you set up the types that you need before you load the family, if you set them up correctly, then at the project they'll be available using the correct subcomponents. Now, what's the deal with the nested share families? So far we can speed up then. So far we have only nested families. The shared families allow us to select, tag and schedule the components separately. For this case, we needed to color code for the scoping elevations the different components that were nested in that family. But because if they are just nested into the family, you cannot pick them up by using the view filter, but you can if they are shared. Okay, I think I'll use this to make it quicker. Okay, how can you tell if a nested family is shared? If you select the component and you click the edit, you'll notice that there's a field here, which in this case is unchecked, meaning that this one is not shared. If you click this one and load it into the project, first into the main family, it will ask you to override. You'll need to say yes. Okay. Let me then just speed up things and create a new okay. So I'll load this family into this new project. It's going to look funny with the surround at the top. Okay, let me place it here. So because the surround element is shared, sorry. Now I can tab select the surround element, meaning that this one is available for you to use it with the view filter. Okay, so let's create just a quick filter here. New, let's like surround. In this case I want to apply it just to the window category because that's the category of the nested shared element. I can use the type name, say that in this case it contains surround, and let's say that I want to change its pattern to solid red. Okay, and then I could do the same for every single nested component. So if I edit the component, check the shared box, and then load it back into the main family, and then load the main family back to the project file, I will have all the nested components available to be, well, in this case, to be filtered by a view filter, where I can do whatever I wish with them. They can be tagged, so if this one here is assigned a mark or a description or whatever, I can just tag it and it will pick from this element's properties, and I can schedule it as well. Another example would be to create an exploded view. For instance, this one is a family, this whole element is a family, but all these elements here, all the sub-elements, they were modeled as separate families, loaded into the main fin family, but they were loaded as shared, so that when creating an exploded view, they could be tab selected and pulled to create this view. Also, the tags are picking up from the subcomponents properties. They're not just text. Okay. Another way of knowing that the elements are shared efficiently is that under the families node, they will show separately. So when I loaded the main family back to my project, every single nested shared element will be loaded as well. Do I have a couple of minutes to explain all the part? Oh, 5 minutes. Okay. So another use for the shared families that we were was to create improved parking bays. So what we have here, so that we could schedule the parking bays more quickly and more efficiently. So let me close this one. Okay. So what we have here is the exact same family, but we have two different nested shared families there. One for the disabled parking and another one for the standard parking. So created the main parking family, nested the disabled and the standard as shared, created the family type, this time using the parking category, and so that it allows you to pick from one of the two. And then on the main family, we've set out to create the disabled base parking and the standard base parking. And then we selected one of the shared families and then just created an array. And to the array, we assigned the number of bays. Okay. Then we loaded the family into, oops, sorry, this is the presentation. We loaded the family back into the project. We have created a parameter for the number of parking bays total, so that we could decide how many parking bays we wanted. Now, how can we schedule that? Because each parking bay, whether it's standard or disabled, is shared. It's listed here under parking. So this is the main family, and these two are shared. Okay, and they can be scheduled. Probably let me just undo all this. So the schedule, when you first create it, is listing every parking family. The main one and the isolated shared nested components. That's why you have these lines here saying disabled parking bay single 4, and then the disabled base also 4. It's double counting because it's counting both the parking base total parameter that is in the main family and in the individual families. So for this schedule, you'll need to filter those. This is the description field, and the quick way of filtering out is just to say to filter all the ones who do not contain, this case, base. Okay, so the ones are filtered out. We're only now looking at the shared families. If we hide this field, which is the type, and we don't really need, we have the correct number for the disabled and the standard base. Sorry, I made it a bit too quick, but this was the hands-on. Any questions about this one? About the shared?
No question, but one other thing you can do with shared families is quite useful. Where you have your example of the window, where you've got the hosted family that's got the bits in it.
Yes.
And then in the main project you can then filter them. You can also, because they're shared, you can, those bits, when you create a type, you can select any other type of window that's in the project and replace it in there, which might sound a bit crazy. But you can, for example, you can have a host family, you can have a standard way of making a shared family, which you would adhere to throughout the project. So then you can just load in your nested families into your main project, and then when you create your types of your different windows, you can have the same opening, but into it you can have any kind of window that you've created in your project, in your practice, as long as you adhere to the same set of parameters and they're linked in properly to their own host family, then you can very quickly create quite a wide range of different configurations.
Yes, you're quite right. Yes.
Which is quite nice.
Yes, very good. Yeah.
And you can also do that similarly. You can have, say for example, a door family with a side light. You can use the same side light nested into the door family, which I
yes.
But you can also use the window family.
Yeah.
So you can couple them together and do something like that.
Yes, absolutely. Yes, good idea. Yeah.
Any other questions?
Just a bit of an additional things in here. That we would do from once you as the family goes share, no way backwards unless you did it then.
like if you want to unshare the family, no, you'll need to go to the main family, delete the shared one. Or, well, first edit the nested one, then delete the nested shared, uncheck the shared, and then purge the main family, and then load it back in. Yes, it's a bit dodgy.
You can rename it inside the family, edit it, rename it inside the family, and then bring it in.
Yes, yeah,
Switch the
yeah,
types out.
yeah, yeah.
But a word of caution, if you are going to use that for things like doors and windows as a matter of course, what we've noticed is if you're exporting out to nav